Oh, come on. Good afternoon, everyone. All right, I know it's post-lunch. Everyone's got a little bit of food coma, but hopefully I'll have an interesting presentation for you. Today we're going to talk about Windows Phone 7 and Windows Azure and how the two of them work well together. My name is Wade Wegner. I'm a technical evangelist for Windows Azure. And so one thing I'd like you to know right off the bat is I am not a Windows Phone 7 expert. I'm sure many of you are in the room. I focus much more on Windows Azure and building scalable services within Windows Azure. However, I have done quite a bit of work with Windows Phone 7 as well. And so the bulk of my talk today is going to be talking through some patterns and ways in which to best leverage Windows Azure for applications you build for Windows Phone 7. My role as a technical evangelist is kind of as outlined here. I do a lot of activities focused on developers. I have a show on Channel 9 that I co-host with Steve Marks called Cloud Cover. So if you ever want to learn a little bit more about the Windows Azure platform and like a little bit of goofy geek humor, definitely check it out. And so also I build a lot of demos, come to conferences and meet and present with folks like you. Now, I have a couple of assumptions about you, and the presentation here is kind of designed around these assumptions. So hopefully these are accurate. If not, I apologize, but I'm trying to gear the presentation towards a particular set of users, and I'm making the assumption that you're a developer, and we're going to focus on development topics here. Also that you are building applications for Windows Phone 7, but you probably are building applications for other mobile platforms as well. Also, since you're here in a talk about Windows Phone 7 and Windows Azure, I'm also making the assumption that you're interested in the Windows Azure platform, which I think is fabulous. In fact, Tina in the back was handing out some cards. If you didn't get a card from her, grab them because they'll give you free access to the Windows Azure platform for 30 days. So then you guys can go off and start building applications using Windows Azure. And so the very first thing I want to talk about is why the phone and cloud? Like what's compelling about using cloud services along with a mobile application? And the first thing is that it levels the playing field. Think about the fact that as an independent developer, I don't have a lot of access to resources, particularly if I end up building an application that gets particularly popular. I don't have the opportunity or the infrastructure to be able to scale to the level that I'd need to end up using to satisfy the users that I have. And so the cloud ends up really leveling the playing field. It gives all of us independents the opportunity to scale to a large extent. We don't have to be a Facebook or a Microsoft or a Yahoo to have the infrastructure in order to satisfy the needs of our users. Also, it gives us a pool of resources that we can tap from. And so by having a pool of resources available, it means that I don't have to start big. I can start small. And as I need to, I can grow in order to satisfy the needs of my users. Also, building out cloud services for our mobile applications gives us the opportunity to start building services that scale across platforms. And so we're not just optimizing for one particular platform or one stack. We have the opportunity to use these services across multiple platforms. And so then why Windows Phone 7 and Windows Azure? First thing to note with Windows Azure, and if you haven't gone to or attended a intro or a 101 presentation on Windows Azure, I'd encourage it. One of the big differentiators for Windows Azure is that it's a platform as a service offering. And the real takeaway there is that you focus on building your application rather than the infrastructure that's used to run it. So you build your application, you deploy your application to Windows Azure, and then we run it for you. You don't have to worry about setting up or configuring operating systems. You don't have to figure out how to scale across multiple instances. You provide the instructions to us, and we run your application for you at scale. As part of that, we can do a lot of nifty things to make sure that your application is running as optimal as possible. For instance, we can do automatic operating system patching. So versus like a traditional hosting model where you'd have to remote into a server and use Windows Update or install some patches, we have the opportunity to keep your application up and running, but patch the underlying operating system in a rolling fashion so that you have no downtime on your application, but you can make sure that you always have the latest security patches, the latest hotfixes and so forth deployed and installed into your operating system. Windows Azure also gives you a way to build highly scalable applications, both from the perspective of your compute resources that are running your services and web applications, in addition to the data that you store and use within your applications. And so we can scale and build highly scalable services for data as well as compute. And finally, it's a utility billing platform. And what I mean by utility billing is you only end up paying for the resources that you use, be it a set of instances that you've got deployed running your web services and websites, or the amount of stuff that you have stored in storage, your network bandwidth consumption, things like that. So there's a predictable model based on the way in which you use and consume the services in the platform. We also have a lot of additional services built on top of Windows Azure. And throughout this presentation, I'll talk about some of them. But things like the access control service that gives us the ability to perform identity federation against existing social identity providers like Live ID or Google or Facebook. Even corporate accounts such as Active Directory through ADFS. We have something called the Traffic Manager, which provides load balancing across data centers so that you can build globally redundant systems worldwide so that your application is always closest to your users. We have a caching, an in-memory distributed caching service where you can put your data for very fast access. We also have a CDN, or a content delivery network, that you can use to make sure that your static resources, such as files and movies, are as close to your users as possible. So the Windows Azure platform is more than just storage and compute. It's all these additional services as well. And then finally, if you're familiar with developing with the Microsoft stack, you're going to be familiar with developing for Windows Azure, and for Windows Phone 7 for that matter. Visual Studio, .NET languages. In fact, we even have emulators so that you can do all your development locally, both from the Windows Phone 7 perspective as well as the Windows Azure perspective. So these are some of the reasons why I think Windows Phone 7 and Windows Azure work particularly well with each other. And so right off the bat, I want to show you a demonstration of an application that I've built using a toolkit that I'll show you in a little bit, but also using services that are running and hosted in Windows Azure. And I call this application BabbleCam. And what this application does is allows you to take a picture of some text. And when you take a picture of this text, it will take the image, push it up into Windows Azure, and it will run it through an OCR service so that it'll extract the text out of it. And then it'll send that text back to your device so that you can see whatever the image that the text on that image is. In fact, you can also hook it into the Bing translator service so that if it's in a language that you don't understand, after the OCR service extracts the text from it, it'll also pass it through a translator. So I've got this application here called BabbleCam, and I'm going to go ahead and open it up. And you can see I've got a couple of pivots here. I've got recent babbles, and then I can also look at babbles that I've translated or processed in the past. And so what I'm going to do is go ahead and create a new one. So I'm going to go ahead and turn on the camera. And I've got some text right here. Let me go ahead and take a picture of this. So you can see here that I've taken this picture. Oops, sorry. There we go. So here it is. You can see down here we've got, or maybe you can't quite focus. It's essentially a list picker where I can choose the originating language and even choose the language that I want it translated to. I'm going to go ahead and upload it. And so this is pushing this image up into blob storage in Windows Azure. And once it's pushed there, my services running in Windows Azure are going to go ahead and grab that image, run it through my OCR service, extract the text, look to see if I want to perform a translation on it, and then send me back the data. And so in fact, I can come here to my babbles, and let's do a refresh, and you can see here that we've just updated it. And let's see if I can focus this a little bit. Oh, that's worse. All right, well, here's the translated image, or the text that's been extracted off of it. All right, well, I'll read it to you. Microsoft Azure tool developers in its quest to get developers on Apple's iOS platform, blah, blah, blah. So it does a pretty good job. In fact, I can select it, and it'll pull up the original image. And so you can see here, this is the image that it used for the OCR service. So kind of neat. And then let me show you one other aspect of it. I'm going to take another picture, and this time I'm using text that's in French. And so you can see here, here's the text. Go ahead and accept it. And this time I'm going to say that the originating language is French and upload it. So in addition to running the OCR service to process that image and extract the text, it's going to hand it off to the Bing translator service and perform a translation from French to English. And so when this is done after a few moments, we'll do a refresh and see how well it did. One thing I'll note is that as it's processing, one of the values of having this OCR service running in Windows Azure is the fact that sometimes the image quality isn't particularly good, and so the OCR service is only as good as the image you process. So one thing that the Windows Azure services do is it creates a couple of different copies of my image, and it will adjust brightness, contrast, it'll turn it to black and white, and it'll run all of those different versions of that image through the OCR service. And then it'll figure out what is the most accurate processing of each of those images, and it'll use that text. And so the ability to be able to scale through the services with Windows Azure with these cloud services is particularly valuable. And so now you can see here it performed the translation. It says Microsoft offers the iOS and Android, blah, 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 rely on Windows Azure provides, and so forth. So kind of an interesting look at an application. I can, again, select this here and pull up the image, the original image that was loaded up in blob storage. So that's BabbleCam. Now let's take a look at what we saw with BabbleCam. And so here I've got all the different components of the demonstration broken out, and we'll walk through exactly what's going on. On the top, you'll see we've got Windows Azure Storage. In the cloud, we've got Windows Azure, which has our compute and is where we're hosting and running our services. And then below, we've got Bing Translator, which will assist us in translations. And then we've also got the Microsoft Push Notification Service. And so the very first thing that happens in this scenario is that we perform a user authorization. Now, you didn't see this because it's cached the user credentials, but I'll show you in a moment how this works. But essentially, what's happening is we log in to our service, and we get back an access token. Now, each time that we interact with our set of services here on out, we utilize this cached access token so that we don't always have to perform a login whenever we interact with services in Windows Azure. So the access token gives us the ability to continue to use resources in the cloud without always having to perform individual authentications. Now, the next thing we did is, using that token, we uploaded the image that we took into Windows Azure Storage. And so the first thing that we'll end up doing is we're going to use a service that's running in Windows Azure Storage to give us what's called a shared access signature. Now, a shared access signature is a resource that you can use to give access to your storage accounts without having to have account information on the device. So with Windows Azure Storage, to interact with it, you have what's called an account name and account key. These are the equivalent of having a username and password. And we don't want to have these usernames and passwords on the device, because if someone does something and is able to get access to that device, suddenly we've lost our secure username and password. And so what we do is we use a shared access signature that's generated by services in Windows Azure. And when we interact with blob storage, we're going to use that shared access signature rather than the underlying token and keys. And so once we get that shared access signature, we can take the image that was taken and deploy it up into Windows Azure storage. That shared access signature gets embedded in the request header. So when it makes the request to Windows Azure Storage is able to extract that shared access signature out of the request header and authenticate us and grant us the ability to write into blob storage. The next step is to actually do the image processing. And so there's a service running in Windows Azure that will occasionally check storage to see if there's any new images to process. And if there are, it's going to grab that image and pull it into the service so that it can start doing its processing. And the processing that it'll do is it'll run through that OCR service. In fact, it'll run through multiple versions of the OCR service so that it gets the best extraction of text as possible. And when that's completed, it's going to send the text to the Bing Translator service, where we're going to get a translation back. And so Windows Azure is able to, these services running in Windows Azure are doing this processing for us, and then they can work with the Bing Translator service, or really any service that you want to use in order to translate the text. Now, the last step is to send a notification to the device. And so this is using the Microsoft Push Notification Service. And essentially what happens here is we take that translated text and we send it along to the Microsoft Push Notification Service with some channel information that's specific to the device. And once it receives that channel information, it's able to actually send the information down to the device. So this is kind of a walkthrough of everything that took place here in the BabbleCam demonstration. And so there's a lot of different components here. And what I want to do is walk through these components because there's a lot of different patterns that are really useful, and there's different ways of using this within Windows Azure. And so we took a look at identity for access and identity authorization and authentication. There's a storage component. So storing resources, having those resources available to the device and to services running in Windows Azure. We've got services like the OCR service running in Windows Azure. Also, we've got a service that provides the shared access signature for us to interact with our storage accounts. Communications, so the push notification channel, so we have the ability to communicate with our device. And so all of these are different components. And now one thing I want to mention is, as we walk through these different patterns, is there's many different ways to go about doing this. Based on my experience and what I've worked on, some of the patterns here that I'm going to walk through are pretty valuable. But certainly there's other ways to do this as well, so there's not one version of the truth here. So the first thing we'll do is talk about identity. And there's a number of different ways in which you can authenticate and authorize users in your applications on your device. Probably the most common is to have your own identity store. And so this is very similar to the ASP.NET membership provider model, where you might use SQL Server and have a set of membership tables where you store users, you store their passwords, and then you have to build the infrastructure on top of it to perform registrations, fixing and sending password hints and so forth when the user can't remember their information and so forth. This is very common. A lot of the apps built for Windows Phone 7 that require some form of authentication use this model. It's a perfectly legitimate model, and you can certainly use this with your applications. You can also hook into a single existing identity system. So Facebook Connect is extremely popular. So if you want to have your applications built where users, when they open up your app, log in with their Facebook information, that's also perfectly legitimate. You could use Live ID or Yahoo, or you could even build a corporate application and use ADFS so that you could use your Active Directory credentials. So this is another identity option that's available to you. And then lastly, you can outsource that identity management entirely to another service. And this is where the Access Control Service fits in. The Access Control Service 2.0, which was released to production in April, gives you the ability to interact with multiple identity stores so that you can offer an option to your user so that they can choose which identity they want to leverage. In fact, what I want to do here is come back to the demo real quick and show you what I skipped over the first time. And in BabbleCam, right now I've got my token cached so that every time I log in, it's just using that access token. But let me go ahead and log out and show you what it would look like. So now that I'm logged out, it's asking me to log back in. And you can see here that I've got Windows Live ID, Yahoo, and Google as options. And so what I want to do is select one of these identity providers. In this case, I'll select Yahoo. And again, it used that cached information. And now when I'm logged in as Yahoo, through my Yahoo account. If I wanted to, let's say, use Windows Live ID, I could select this. In this case, it doesn't have my cached credentials for Windows Live ID. And I can go ahead here and using the keyboard, I could log into the application. So Access Control Service gives you that ability to leverage existing identity stores and then add them or remove them as required. Now, the use of the Windows Azure Access Control Service for Identity Federation is actually particularly, it's not tremendously complex, but there's a lot of components to it. And since we're not focused on identity in this session, what I want to do is call out a really good resource that you can use and walk through to get some insight into it. And this is a hands-on lab that my team has created for authenticating users on the Windows Phone 7 device using Access Control Service. And so you can get to it. Here's a bit.ly link that you can use, bit.ly/WP7ACS. And it'll walk through the process of configuring your identity providers, setting up your relying party, configuring the rules that you can use when logging into the application, and so forth. And then also how you hook it into the Windows Phone 7 device as well. So definitely take a look at that hands-on lab, because that's particularly useful. Now, looking at storage, there's a lot of different storage options up in Windows Azure. One of the more popular ones is using our relational database, SQL Azure. SQL Azure is a service provided that gives you access to a relational data store. It's built on the same common engine as SQL Server, so you get the benefits of the same model and the same programming model that you do with SQL Server. So if you're already building databases that use SQL objects such as table triggers or stored procedures and so forth. All those things translate over to SQL Azure as well. So we haven't changed the development model. But what's nice about it is this is a managed service that we manage for you. So you're not responsible for making sure that everything's clustered and redundant, and if there's failures that you're failing over to a node that's up, or making sure that it's scalable and so forth. It's all part of our responsibility for managing that service for you. So it is a relational database, it's highly available, and we do manage it for you. So SQL Azure is a very good option, especially when you start interacting some services on top of it that I'll walk through in a moment. We also have Windows Azure Tables. And what Windows Azure Tables are, they're a set of structured storage constructs that are designed to give you very, very scalable, a very highly scalable storage service. And so whereas the SQL Azure gives you a relational database model, Windows Azure Tables are not relational. In fact, they're partitioned data by default. And so we start at the very beginning with identifying what the partitioning scheme is for your data, so that as your data grows or as your usage of your data grows, Windows Azure storage services are able to scale that table storage data out for you. So it's non-relational structured storage. It has the ability to massively scale, and it actually has an OData head on top of it. So it's addressable via HTTP, and it uses WCF data services and an OData service head for you to interact with it. And then finally, we have Windows Azure Blobs, and this is what you saw. This is where I deployed the image once I loaded it up into Windows Azure. And so Windows Azure Blobs are a place for you to put very large binary type data. It could be images, it could be video. I've seen people put XML in there. You could put a lot of different things in blob storage. It's, again, all available via HTTP, and in this case, REST. So you can interact with all these services across devices. You can interact with them across platforms. Basically, anything that's able to communicate over HTTP is able to interact with Windows Azure storage services. And so here's some different patterns that you can think about using when walking through some of these storage services. So in this case, SQL Azure. Now, rather than having your device address SQL Azure directly, which would be problematic since SQL Azure uses TDS as the underlying protocol, basically the pattern here is to put a service on top of it. And so a very common service to use is an OData service. And so here in this case, let's say I want to write some data into SQL Azure. The pattern would be for my device to send data to that OData service. Now, presumably, we're also having the user authenticate as well. So maybe in that request header, there's a token, some kind of authorization token that allows me to perform this operation. But the idea is that we're proxying the insert or the read to SQL Azure through this service. So we're going to send some data to that service. That service is then going to store it in SQL Azure. And if it's a GET, it could also do a select or perform some sort of operation to get data out of SQL Azure as well. With Windows Azure Blobs, we have very similar patterns. Let's say, for instance, that we're interacting with some publicly available blobs. So let's say these are images that I want to load within my web application, or they're images that I want to put in Windows Azure storage and then make available to my mobile clients so that people can pull these images down. A pattern for being able to write to these would be to send that image. So if I want to be able to upload the image, I would send that image to the service and send it to the web role itself, and then let the web role be responsible for doing the write. And there's a reason for doing this. Even though Windows Azure Blob Storage has the concept of read-only data, you cannot do a write against it unless you provide the appropriate access control or the access token. And so rather than putting that token on the device, where again someone would be able to get access to it, you'd have your service or your application running in Windows Azure use the token to do the write. So you proxy the upload of the image through your services in Windows Azure so that you don't have to put the token on the device, because we don't want that secured information to become available to anyone to start accessing it. Because as soon as they have access to that token, you no longer have secured storage. And then finally, once that image is available, the device can address that image directly. Since it's publicly available as a read-only image, you can just do an HTTP GET against it out of storage. So it makes it very easy for you to access this read-only blob information directly from your device. So again, we have the concept here of proxying through a service in order to do uploads and reads of public blobs. Now, on the flip side, I mentioned here's another pattern. This certainly is possible, but I would caution you away from it unless you really don't care. But if you do have the access token on the device, you can do the write directly to blob storage. Certainly possible, but again, now you've put the token on the device, which may not be the most secure place to place it. Now, in the Babblecam scenario, I showed you shared access signatures. And what shared access signatures is essentially doing is we're going to call out to a service running in Windows Azure, and we're going to say, please generate a shared access signature that I can use so that I can address a private storage account directly and perform a write or a read and so forth. Now, the reason this is valuable is sometimes when you're interacting with large data in Windows Azure Storage, you don't want to proxy the upload or the download of that resource through a service. You want to be able to go directly against the storage service. At the same time, if you don't put the access control token on the device, there's no way for you to address it. And so this is where shared access signatures comes into play. And essentially, shared access signature is a policy that you can define that when it gets sent back to the client, it can then embed that in the request header that's sent to Windows Azure Storage, and it will be used to grant it temporary access to those resources. So in this pattern, you can use that shared access signature as a way to write that data to your storage account, or even perform a read against a private storage account. And then, again, you can use that shared access signature to fetch that data on a public blob or even on a private blob. So it's, Windows Azure Tables doesn't have the concept of a shared access signature. Additionally, Windows Azure Tables doesn't have the concept of having public read-only data as well. So everything in table storage is always secure by default. And so you have to proxy through some kind of service if you don't put the token on the device. So again, in this case, if you want to write data to Windows Azure Table Storage, you would write it to a service running in Windows Azure, and that service, which has the token as part of the service, would perform the write for you in Windows Azure Table Storage. So this way you don't bleed the key down to the device, but you still have a way to securely interact with your table storage service. The net takeaway that I would mention here, and just I emphasized it many times, is to really be cautious about putting secured keys in storage. So a pattern would be to use isolated storage on the Windows Phone 7 device and to cache the username password, or to cache an access control service token or Windows Azure storage token. Really think about whether or not that's the right thing to do or not. And the patterns that we walked through, in every way, there's a way to do it by proxying through a service running in Windows Azure so that you don't have to put that token and those secrets onto the phone. Now next, let's take a look at services. So these would be services running up in Windows Azure. We have two concepts of a service, or what we call a role, in Windows Azure. We have a web role and a worker role. The primary difference between the two is that a web role already has IIS installed and configured into it. So you would use a web role whenever you want to host either a service or a website in IIS. The worker role does not have IIS. Essentially, you can use a worker role whenever you need to do some kind of background processing. So think of it as kind of a DLL with a main statement in it. So it's very analogous to having a Windows service running on Windows Azure. You'd have this processing running in the background. The example in Babblecam is that the website that I use for managing it is running in a web role. The image processing that has the OCR service, well, that doesn't have a website or a service endpoint that I address directly. So what it's doing is it's a worker role that's independent of the web assets. And so the worker role can be a place for you to run a lot of these operations in the background. One thing to note is that in both cases, both on a web role and in a worker role, we implement the role entry point in Windows Azure. Now, the role entry point is essentially a hook where we can call into your code. So we use it to start up your processes. We use it to check on them, to restart them if we need to. And we also use the role entry point to call in and stop your processes as well if we need to. And so the reason this is interesting is the worker role is really nothing more than the role entry point with the run statement where you can have your code launched. The web role also has the role entry point. So in theory and in practice, you can use the web role to both do the hosting of your services in IS, as well as background processing for something that you might use in a worker role. So if you want to start looking at collapsing some of your services into a single set of role instances, the web role gives you the benefit of both the worker role and the web role with IS. Of course, that may break some scaling patterns that we'll talk about in a moment, but if you're looking to consolidate resources, you can use the run method that's provided by the role entry point as a hook to call into your code, even in a web role. Now, one thing to note is the reason we have these concepts of a web role and a worker role is that we can provide some patterns for scaling your services. And so what I mean by this is you may have a web role that's running your website or your web services, and then you've got a worker role that's doing some processing. And you might want to, and you probably will want to, scale these independently so that you don't always have to scale your composite app all as one. So take an example here where I've got a set of web roles that are receiving messages. When they receive these messages, I want to pass this along to the worker role that's doing the processing. And so what we use here is Windows Azure Storage queues as an intermediary, because we can write that information to a queue, and then from a set of worker roles that are also running somewhere in Windows Azure, we can extract or dequeue that information and do the processing in the worker role. And so a pattern with Windows Phone clients is that we might put information into a queue, have a set of worker roles responsible for getting that information, and then those worker roles could do things like sending push notifications and so forth to devices. And the benefit of this is now I can scale my different tiers of my application independently. If I need to scale my website to service more users on my website or to be able to handle more requests, HTTP requests to my services, I can scale up my web roles, and conversely, I can scale them down if I need to. At the same time, if I'm doing a lot of background processing or if I'm processing a lot of push notification messages and so forth, I can scale my back-end worker role independent of my website. And yet they can still communicate to each other through a set of queues, isolating each and kind of abstracting the works between a different set of instances. So this is a very common pattern for scaling in Windows Azure. In fact, if you guys saw some of the announcements, I think it was 2 weeks ago, where we released the Groupon application. Groupon is working on building push notification support in their applications, and the architecture that they use is very similar to this, so that the running of their services is decoupled from the push notification processes, so they have the ability to scale these things independently. And I alluded to this, but, oh, actually, no, I didn't. I'm sorry. One other thing to note, and this is, I think, pretty interesting, especially as you start building more and more applications for your phone device that use different services, is that in your web role, you can make them multi-tenant so that you can run more than one website or more than one set of web services in a single set of role instances in Windows Azure. And you can do that because in the service model that you use to describe your application, you have these tags, the site tags, which is analogous to the way in which you also specify resources for IIS. And you can see here that in sites, in the sites collection, I've got two sites. I've got a web and a web 2. And each of these point to a different set of physical resources. They manifest themselves as different sites in IIS, and they even use different app pools. So it allows me to build multi-tenant solutions in Windows Azure so that I can host more than one application. So especially if you're looking at the monetary cost of running a set of services in here, this is a great option for consolidating services that service multiple Windows Phone applications in a single set of Windows Azure role instances. So definitely consider using this type of pattern for multi-tenancy within your application. The next thing to consider is the Content Delivery Network service. And so what the Content Delivery Network, or the CDN, is, essentially we've got 24 CDN nodes worldwide. And what we use them for is caching data closer to users. So those images that you may store up in Windows Azure Storage that you want to be able to let a user pull down. Well, let's say your storage service account is set up somewhere in the US or somewhere in Europe or Asia. You don't always want to make that user have to go all the way to the data center and then do that pull, because there's going to be a lot of latency involved in consuming a service running in Europe from North America and vice versa. And so you can use the Content Delivery Network as a way to get your resources closer to your end user. And so the way that it works is, with these CDN nodes, we've got the nodes distributed worldwide. when a user makes a request for this resource, they make the request to a DNS name that's connected to the content delivery network. And what it's going to do is send the user to the closest CDN based on the latency. And the user is going to check to see if the resource they're looking for is in the CDN. If it's not, meaning that it hasn't been cached yet, it's going to go to the storage service, grab the resource, and then pull it down to the CDN, where it'll be cached and then returned. So for that first user, they're still paying the penalty of having to go back to Windows Azure Storage, wherever that may be, in order to get that resource. However, any other users that then try to access that resource and they hit the CDN, they'll have that cached version of the resource in the CDN node, so they will only have to make the initial request and they'll be able to pull it back directly from the CDN node. So it reduces the latency and time it takes to round trip significantly. And so using the CDN along with your resources when building out mobile apps is a great way to reduce the latency on calls to those resources. Similarly, you may have a global audience, or even, it may not even be a global audience. Maybe it's an audience that's in a certain geo. Maybe it's, you're targeting North America or Europe or Asia, and you have users in the East that don't want to necessarily call to the data center that's running somewhere in the West. And so what are some of the things that you need to be concerned about? So for instance, if I deploy my set of services into our North American data center, I get great latency, very low latency rather, for all my users in North America. But as I start to get a wider user base and we start going further and further away, every time I call to my services, that latency grows. And so by the time I get to Europe, the time in order to respond to those calls because of the physical distance grows and grows. And so what do we do in order to reduce this latency and actually target a global audience? And this is where the Windows Azure Traffic Manager comes in, because the Traffic Manager will end up doing load balancing across data centers. So for instance, I can deploy my application, my same application, into each one of the data centers. And then using the Traffic Manager, when my user makes a request against my service, again via DNS, we can determine what the lowest latency is to each of the data centers and route the request accordingly. So now if my user is located somewhere in Asia, when they make the request to my service, they're going to be routed to my application deployed in the Asia geo. Similarly, if I've got a user in Europe, they're going to be routed to the nearest data center in Europe, and so forth for North America. And so this allows us to start managing the performance and routing users accordingly based on where they are physically located. One thing that a couple other things that the Traffic Manager does too is gives us the ability to handle failures. So let's say, heaven forbid, a data center goes down. Someone cuts the fiber optic cable or something like that. What do you do? If you've got your application just deployed to a data center in North America, how are you going to start servicing it? And so Traffic Manager has a way to check the health of your services running so that if, for instance, something happens to a data center, or even if something just happens to your service, maybe there's a software failure or you have a device or disk crash in the data center, it's able to detect that the resource is no longer available and then route to a different data center. So you can get some redundancy across your applications. So the Windows Azure Traffic Manager is another service that's particularly useful here. All right, so that's services. Now let's talk a little bit about communications. There's a couple of different patterns for communications for the phone. And in a high level, we can call these phone-initiated, meaning that the phone is calling or polling to a resource running somewhere, Windows Azure or some hoster or something like that. Or they could be cloud-initiated. So for instance, the push notification service is able to use a channel to write down to the device. With phone-initiated communication, there's some typical ways in which you go about doing it. For the most part, it's all HTTP-based. So you're using common HTTP protocol to do a request and get a response back from a service. There's a lot of different frameworks that you're most likely familiar with in order to do this. You can use WCF, you can use OData, you can even make raw web requests to resources as well. So what you're doing here is you're essentially polling a resource, or you're going out and getting, you're calling to the service to get some kind of information back. And then also there's a number of different formats that you can use here. SOAP, which may be very fluent, but it's also very verbose, which doesn't make it work particularly well sometimes for mobile applications. You could use JSON, which is not nearly as verbose, and so becomes a lot more efficient mechanism for, or wire format for pushing data down to the phone, and so forth. So you could also just use plain old XML. And so phone-initiated communications work really well. One of the challenges is that how do you end up doing something when the application isn't open? Also, what kind of resource impacts are you going to have on the device when the device is constantly having to pull or call out to some service in order to see if there's something that it can get? And that's where the cloud-initiated communications pattern comes into play. And so this is really push notifications. And you saw this, or actually I guess I didn't demonstrate it yet with the BabbleCam. But what push notifications is it will give you the ability to establish a channel between your device and the Microsoft Push Notification Service. And then you can push notifications through the Microsoft Push Notification Service to the device so that you can have it take some sort of action. This makes it a lot better in terms of battery life. So you've only got one open channel with one service rather than having many channels open with many different notification services. It also will limit the need for bandwidth consumption because you can just push a little message down to the phone that tells it to open up an app and get a resource. So you're not making a whole lot of pulls against the service looking for some kind of an update. One thing to note about the Microsoft Push Notification Service, though, is that there's no guarantee of delivery. It makes a best attempt, and honestly, in practice, there is a very good guarantee on it. So there are 3 different types of push notifications. There's raw, and raw is a notification that you can push and then handle within the application. So if you want to send a message to a user when they're in the application, you can send a raw message and then handle that within the app. You can also send a toast so that right from the device, you can push a message down to it, and then it'll pop up a little toast message there saying that you can display whatever the text is and so forth, and essentially just send a toast, very similar to what you might have in a desktop. And then third, you've got the ability to push a notification to a tile. And you can do a number of things with tiles. You can update the tile image, you can change the title of it, or you can even just put a little number, a numeric counter, indicating that it's received some messages. So these are the types of cloud-initiated communication patterns we have with the Windows Phone 7. In order to subscribe to the push notification, here's the model that it uses. The user will first establish a channel. So this will be handled by the application, and it can also be user initiated. So you can request that the user enable notifications rather than just turning them on by default. And so it'll establish a channel with the Microsoft Push Notification Service specific to that device so that the Microsoft Push Notification Service knows how to send a message down to that device. You next have to have a service somewhere that's responsible for sending the messages, and you need to tell that service what the channel is that you're using. And so, for instance, with Windows Azure, that service can run in your web role, and you can send that channel to the service so that it knows how to address your device. So that when you want to send a notification to the device, you can send it to the Microsoft Push Notification Service using that channel, and then that last step is the Microsoft Push Notification Service can send it down to the device. So this gives you the ability to initiate a push from the cloud. So we walked through a lot of different patterns. I mean, we talked about storage, identity, communications, services, and so forth. And one question that we got a lot was, what makes this easier with Windows Azure? Are there any resources that we can use to get started so that we have a leg up? And so what we ended up doing is we've started to create these toolkits, and we call them the Windows Azure Toolkits for Devices. And we've got 2 different flavors of these today. We have a Windows Phone 7 version, which is a great toolkit. There's a lot of automation in Visual Studio. We can produce a lot of resources for you. And it's available as an open source project up on CodePlex. So if you take a look at WA Toolkit, wp7.codeplex.com, you can download the package, and I'll show you what this looks like in a moment, that has all the source code, as well as Visual Studio extensions that get installed to give you new project templates so that you can literally do a file new project and get access to just about every pattern here that we walked through. It gives you services to support the creation of shared access signatures. It gives you the push notification service and the ability to register channels to devices, and all of that stuff as part of the toolkit. Last week, we released the Windows Azure Toolkit for iOS. So if you're building an iOS application, I don't know why you'd want to, but if you are building an iOS application, you can still leverage those same services running in Windows Azure. So again, we get to the advantage of having a set of cloud services. And that's because you can have one set of common infrastructure running in the cloud and then use it and leverage it across multiple device platforms. And so we've made that library, which is an Objective-C library, along with Xcode 4 project templating, in GitHub. So it's fully open source. It's up in GitHub. You can take a look at it today. And then what we also announced last week is that we're working on Android, which takes a little bit longer due to many different reasons. So we're hoping to release an Android toolkit this summer. And so what that will end up being is a Dalvik library for the storage services. So it'll be Dalvik bytecode along with Clips tooling for the application. And again, you'll be able to hook into the same set of services running in Windows Azure. And the toolkits all include native libraries, samples, project templates, documentation, and so forth. And so what we announced yesterday, and if you saw the keynote, you saw Drew Robbins showed you some of the toolkit in his demonstration. He showed you how you can use the toolkit to create a new project. And so yesterday we announced version 1.2. And here's what we added in 1.2 with support for access control services. We included an Apple push notification service so that if you are building an iOS application and using our Objective-C libraries, you can also push messages down to your iOS device as well. We provide support for Windows Azure storage queues, which we hadn't in earlier releases, just tables and blobs. And we also updated the UI and user experience on the management portal. And so what I want to do is walk through this toolkit and show you how we can build some applications. So I mentioned where the resources are located. Let me just show you again in case you didn't catch it. It's up on CodePlex, WA Toolkit WP7. And we also have the Objective-C libraries available here up at github.com/Microsoft-DPE. So you can grab all those resources here. And so what I'm going to do is I've already downloaded the resources. In fact, if we come here, what the resource does is it unpacks a set of resources here on your disk. So it doesn't register anything. It's essentially a self-extracting executable file that provides a bunch of resources for you. You can run the setup command script here to, one, initiate a dependency checker to make sure that you have everything you need installed on the machine, because sometimes it's difficult to set up development environments. You need to make sure you have the Windows Identity Foundation runtime installed. You need to make sure you have the Windows Phone tools. You need to have the January update. I mean, there's a laundry list of things that you need to have sometimes to successfully build these applications. And so as part of the toolkit here, we provided a dependency checker to make sure that you have everything installed. The dependency checker also, or excuse me, this wizard, the setup command, will also install the Visual Studio extensions so that you get the project templating as well. So if you can see here, if I go to Extensions Manager, I've got the WA Toolkit for WP7 installed. Now what that gives me is the ability to, say, a file new project. And if you've built Windows Azure applications before, you're probably familiar with the Windows Azure project. This is installed with the Windows Azure SDK, but you're most likely not familiar with the Windows Phone 7 cloud application as well as the Windows Phone 7 empty cloud application. And so what these are, they're templates that are created so that you can very easily create an application that includes an application built and running for Windows Phone 7, as well as all the services that you use in Windows Azure to support that application. And the empty version is just what you'd expect. It's an empty Windows Phone 7 project. The cloud application includes a sample app that leverages the library, that leverages all the services, and gives you an entry point into it. It's very similar with the ASP.NET templating, where you have a default ASP.NET web application that has an app in it versus the empty ASP.NET web application. So what I'm going to do is create a new project. And you can see here, let me go ahead and maximize this. We have a wizard that will pop up and start asking for some information. So for instance, if I want to use Windows Azure Storage, I'm going to need to have a name and a key associated with it. And so the wizard will prompt me for entering this, and then it will register the name and the key in the appropriate place within the Windows Azure project that gets created. And again, we put it on the services side because we don't want to put the key on the device. And so that way the service is responsible for proxying and authorizing access to my secured storage. You can also just choose, and this is what I'm going to do for the demo, to use the local storage emulator. So this way I can do all my development locally. In fact, on the way here, I was able to do this on an airplane because you have full local emulation support, both for Windows Phone 7 as well as Windows Azure. Now, if your application, if you want to use push notification, you can also enable or disable, if you don't want to use it, the Microsoft Push Notification Service. And if you remove it, we're just simply not going to create the service and register you for it within the device. And you can also just choose to turn on the Apple Push Notification Service if you want to use it from an iOS device. I'm going to go ahead and click Next. Then the next step is to ask what kind of authentication model you want to use. ASP.NET Membership Store is the default. So essentially, what we do is we use the membership provider model, and we create a set of tables in Windows Azure where we will store usernames, passwords, and that membership information about your users. And then when a user goes to log in, they'll log in with a username and a password, and they'll get back a token provided by our services. And then that way, as they authenticate against services moving forward, they can always embed that token into the request header so that they can gain access to those services. What you can also do, and I'll demonstrate this both ways, is choose to use the access control service. And if you use the access control service, you'll need to provide your access control service namespace along with the management key. And what the tooling will do is then call out to your access control service, register the identity providers you use, and then update the project so that it's hooked into the access control service. For this first demo, though, I'm just going to use the ASP.NET Membership Store, and then we'll come back if there's time to the ACS. So I'll go ahead and click OK. And at this point, it's creating the solution, and it's going to create 3 different projects for us. So you can see in the top, we've got this Windows Phone 7 Cloud App 7. What this is this is the Windows Azure project itself. So when you build an application for Windows Azure, I told you that you focus on the app, not the infrastructure. And so this Windows Azure project is essentially responsible for creating our cloud package and then helping us as we deploy it up into Windows Azure. So you can see here we've defined what the roles are, and it points to the project for each one of those roles. Also, we've got the service definition and configuration files that we can use to control which resources it's using and some other aspects of it. I've also got this phone project, go back in here, which is our Windows Phone 7 project. And since I didn't choose the empty project, it's also created the sample app as part of it. And what you'll see here is that we have a number of things referenced in here. So for instance, one of the assets that we deliver is a storage client library for Windows Azure that you can use on the phone. And so we've already taken the compiled assembly and added it as a reference. And we've hooked in other stuff as well, the controls toolkit and some other things as well. So the services and assemblies you need are already added. And then last at the bottom here, we've got this web project. So it's a web application. It's our web role for Windows Azure. And here is where we have all the services that you'll use and that get deployed into Windows Azure. Also, it's this web config here that has a lot of the specifics about the service, such as you can see here. Here's the definition for our membership provider, in which we use the table storage membership provider, and some other things as well. It registers our notification services and so forth. So one of the things that's nice about this new project experience is that once you create the project, you can literally hit F5, and it's going to start up the phone emulator as well as the compute emulator and deploy our application and services into them. And we have full fidelity against our application locally here on my PC. And so this will take a moment just to deploy. Here I can open up the compute emulator, and you can see the compute emulator is essentially reproducing what Windows Azure is doing up in the cloud. It allows me to host services, it'll load balance those services, and so forth. And now my app is launched. Now, one thing to note here is you can see here that I've got a certificate warning. And the reason is all the communications that we're doing from the phone to our cloud services are done over SSL. Now, for the templating here and for the tooling, we generate a self-signed cert that we use in the services running in Windows Azure, and we'll also use it on the Windows Phone 7 device. Now, because it's a self-signed cert not provided by a trusted authority, you're going to get a warning that says, hey, do you trust this certificate? It's a perfectly valid cert, but it's not, it's a self-signed cert, so you get this warning. So for the web app, we can just go ahead and say, click continue to this website, and you'll see that we can render this website. the experience is a little bit different on the phone emulator. And that's because, unlike the browser, the Windows Phone 7 does not let you just say, yes, go ahead and trust this certificate. It's going to block it. So if it's a self-signed cert and not provided by a trusted authority, the phone just won't accept it, and you won't be able to access those resources over SSL. And so what we can do here, and we provide the support as part of the experience, is you can install that certificate locally, so that once you register that certificate in the emulator, you can access you can access the site even though it's a self-signed cert. So you can go ahead here, and this is a link to the certificate. It'll open it up. We can just go ahead and click the .cer file. It'll prompt us to install the certificate, and we've installed it successfully. And so now, even though it's a self-signed cert, which frankly we need as part of the development experience here, we can now access these resources securely. And so the app here lets us log in, create stuff. Now, I don't have a user created here, so I'm going to go ahead and create a new one. Call it demo user, and give it a non-existent email address and a very secure password. And we'll register. And you can see here that it was registered successfully, which means that it's communicated to the services running in our Windows Azure Compute emulator, because the whole registration process is done over services. Once we click OK, now we have the ability to log in. Now, one thing to note is you can see here that we've got the ability to say, remember me. And this is a nice way. What we do here is, when you say remember me, when you log in and get back the token from your membership services, it will take the token, encrypt it, and then store it in isolated storage. Now, it's a short-lived token, so it expires. And that's because we don't have a particularly, it's not that it's insecure, but you want to be cautious about securing or storing any details for the user, like usernames, password, and so forth, on the device. And so a lot of applications will take a token that will expire, so it's a short-lived token, encrypt it, and then store it on the device, so that the next time you don't necessarily get prompted for logging in. And so if you use that Remember Me capability, that's what we'll be doing. So for instance, now if I come back here and open the application again, I won't get prompted to log in because it's able to use that token that's been stored. Now, one of the really nice things is the support for push notifications right off the bat. So you can see here right now is we have the ability to enable push notifications. So let me come back to the website, because I'm going to use our web application as part of this demonstration. Oop, not register. I'm going to go ahead and log in. And so we have a default administrator login. And I'm going to come here to push notifications, and you'll see that I don't have any channels registered for my device. And so what I can do is, with the app, I can go ahead and enable the notification, and it's going to register with the push notification service. And you can see here it's successfully connected. So the app updates so that it says connected. And if I come back to my site, you'll see that I have that channel registered with our application. So it knows how to address the device through the Microsoft push notification service. And so now we can do some things and test out some stuff. So let's send a test raw message. And over here, I can click Send Raw. And you can see that that raw message got sent directly into our application. So we're able to do a push notification, specify that it's a raw message, and then handle it and show it within our app. And so you can do this and send multiple messages down. So this is a great way to demonstrate how to do cloud-initiated communication directly to your application. Furthermore, we can use Toast and Tile. So if I come back to the app, and let me first pin it. What I can now do is send a test tile message. So you can see here that it updated the tile. So now we've got a numeric update saying that a message has been pushed. And then I can send another one, and it'll increment that up to 2. And then I can even send a toast. So you can see here's the toast message. In fact, we can click it, and it'll open up our application. Now, one of the really nice things here is that you'll see we are displaying the toast and tile messages within the app. Now, one thing to note is with the notification services, this is somewhat manual today, because if you get the toast and if you select the toast, it's not going to automatically be able to pull that message into your application. There's no way to use like linking or anything like that to display the message. And so what the application uses here is a pattern where every time you send a toast or a tile message to the device, we also register it in a Windows Azure table so that when the application opens up the next time, it will check to see, hey, were any messages pushed via toast or tile to the app that we haven't loaded and displayed in the application, and then it'll go ahead and display them. So this is a nice way if, let's say, you're building an application and you've got some discount or something like that, and you want to send a toast to a user to notify them, you may not be able to display the entire message in that short area for the toast. So you send it down. They only see the first, first however many characters of it. But when they select it and they open up the application, you can display the entire message to them. So that's also provided within the sample. So that's notifications, and so that provides us this cloud-initiated pattern for sending information down to the device. We also have a demonstration of here how to interact with the storage services as well. So for instance, here you'll see that I've got a list of tables. And so we're just iterating against the storage service and showing all the tables. In fact, I don't want to. I'm not going to delete these tables, but you can even delete them. So here I'm going to go ahead and create a new table. In fact, I'll create a couple of tables. And that demonstrates the fact that through the API and the services, we're able to create new tables. You could specify any table name that you want through the API, and I can even go ahead and select them for deletion. Now, one of the things that's interesting is we've authorized, the user's authenticated and they're interacting with storage, but sometimes you also want to provide authorization on top of it so that certain users are able to read, delete, or create resources within storage. And so if you come back to the website for tables, what you'll see is that we also have an authorization model built on top of storage. So my user here, demo user, you can see this is checked. He has access to this table. Now, if I remove that access and come back to my app and try to delete it, what you'll see down here is an error. You have no permission to use this table. And that's because I removed the indicator that I was authorized to interact with that table. And now I can come back here and I could add it, and now I can go ahead and delete it. So it's a very handy way of providing authorization support on top of these assets running in Windows Azure Storage. The same thing goes for data within it as well, or data within queues, and I'll demonstrate that in a moment. On this pivot, we have some sample data, and what this is a demonstration of is the fact that we can create new data and even specify what the schema is within the app. So here we've got some sample data. We've got a model defined in our Windows Phone 7 app that's just a .NET object that's registered as a model, and when we create it, we're able to create an instance of that object here in the app. So I can say Wade Wegner, technical evangelist. And the number really doesn't mean anything. It's just a way to demonstrate the fact that we can handle other data types as well. Go ahead and save that. And now you can see here we have that information. So I could generate a bunch of different data. This is, I've seen a number of folks use the toolkit for using this for things like leaderboards and so forth, so that if you've built an application that multiple users use, you can just use table storage as a place to store leaderboard information. You can store settings specific to users and so forth just using this storage service. And the fact that we provide authorizations on top of it means that you can also give people read access to it, but not write and delete and so forth. Although if you do want to delete it, you can come in here and just go ahead and delete things. So that's tables. Blobs, you saw a much better demonstration of blobs in the BabbleCam demo, but I'll go ahead and show this anyways here. You have the ability to list blobs. Right now I don't have any found, so I can go ahead and create one. I can hook into the camera on the device. You guys are probably aware of the fact that when you use the emulator here, you get a pretty boring picture. A white background with a small little black box. But at any rate, I can go ahead and choose a name for it. Simple pick. And then go ahead and upload this into storage. So you can see we've loaded it here. Now when we come back, when we list blobs, we'll see here's our picture. There's the thumbnail of it. You can even select it and take a look at it since it's hosted in a public read-only container. And then lastly, we want to demonstrate the new support for queues. And this is actually something that we got a lot of requests for, because people want to be able to use a mobile device to store a work item in a queue and then have some other processes running in the background up in Windows Azure responsible for dequeuing the instruction and then doing some processing offline. For instance, the OCR service is notified of a message stored in Windows Azure Blob Storage by the fact that I write an item in the queue telling it to now go off into storage and grab this resource. And so we have the ability to demonstrate this. So I can create queues. You can see here I have the same concept where I can disable access to it, and now the user can't delete it, or I can delete them. Something else what else you can do is you can come to the queue and go ahead and test. Let's just queue up a bunch of stuff. So I'm going to add 1, 2, 3, 4. So what I've done is I've added 4 items into the queue, and then a simple dequeue operation here where I can pull them out. So pretty handy for when you want to start isolating the processing of work outside of your mobile application. Queues are a great way to interact with a service running somewhere else. And so that's the toolkit. So we provide all of this out of the box, and as part of it, if you come here to the samples folder and come here to take a look at the C#, we provide the full source code. So if you want to take a look at how we've implemented the storage client library, or how membership works and so forth, all that source is there, and you have the ability to modify it as required by your use cases. So there's the toolkit. And then similarly, for the iOS toolkit up here in GitHub, if you grab the samples and the library and the documentation from the GitHub repositories, you'll see very similar capabilities. Although, be honest, the tooling is not nearly as nice in Xcode 4 as it is in Visual Studio. So, but that may not be a surprise. All right, so we've got a few minutes left, so we actually have time for questions, which is great. Just as a quick summary, though, the phone and cloud scenarios are pretty powerful. I'm no analyst and no visionary, but there are others that are analysts and visionaries, and a lot of people are kind of betting on this next wave of mobile applications using tremendous power running services powered by cloud. So it's a pretty compelling scenario. Definitely in terms of considerations, think through your identity strategy. Are you going to have your own identity store? Are you going to outsource it to a service like Access Control Service? Storage, what kind of storage do you need? Do you need relational data? And what's the pattern for interacting with it? So like an OData service on top of SQL Azure. Can you use blob storage, table storage, and so forth? Services that are available to you within Windows Azure. So not just the compute services where you run your application, but also services like Traffic Manager or the CDN. Even the Windows Azure App Fabric caching service, which is in-memory distributed cache, are all things that you can leverage for your phone applications. And then finally, some of the communication patterns. So kind of the polling pattern where it's phone initiated and you call out and pull down information, or the cloud initiated where you're able to push information down to the device. And then finally, we've got the 3 toolkits, the Windows Phone 7 one, which I demonstrated and showed to you guys, as well as the iOS and forthcoming Android. Let's see. It looks like there's a lot of resources for the track. I trust that you all have seen this and are fully aware of all the resources available to you. Also, if you didn't get a card that gives you free access to Windows Azure, let me know or come by the booth later and find Tina. She's got a whole stack of cards that gives you 30 days of free access, and a bunch of other resources. All right, and with that, we've got about 7 more minutes, so I would love to take some questions, and even more, if you guys have any feedback, if there's anyone here in the room that's used any of the toolkits, I'd love to, and feel free to come by after the fact as well. But yeah, so time for Q&A. Thank you guys very much. I appreciate your attendance here. Hope you found this interesting.